This is section 5.7, which is solving an equation by completing the square. Their first problem is to rewrite the equation in vertex form. The first step is to write the given equation, y equals x squared plus 4x minus 7. The second step is to move c to the y side. In this case, c is negative 7. You end up with y plus 7 equals x squared plus 4x. The third step is using the formula b over 2 squared to complete the square and add that number to both sides. The b is 4, so 4 over 2 squared equals 4. You add this to both sides and get y plus 7 plus 4 equals x squared plus 4x plus 4. The fourth step is to factor both sides and then combine them. You get y plus 11 equals, in parentheses, x plus 2 squared. The last step is to rearrange into vertex form. This ends up being your final answer of y equals, in parentheses, x plus 2 squared minus 11. The second problem is to use this graph to answer the following questions. The first part of this problem is to find the vertex of the graph of the function by completing the square. The first step is to take the given equation, which is h equals negative 0.01 x squared plus 1.18 x plus 2. The second step is using a graphing calculator to find the vertex. The vertex ends up being 59 for the x and 36.81 for y. This is what it would look like if you found it on your graphing calculator. The second part of this question is, what is the maximum height of the point? The first step is to look at the vertex. The y-intercept will be your answer. The answer is 36.81 feet. The next question is, the nearest defensive player is 5 feet horizontally from the point of impact. How high must the ball go before it hit the ground? The first step is to take the given equation, which is h equals negative 0.01 x squared plus 1.18 x plus 2. The second step is to fill in 5 for all the x values in the equation. You get h equals negative 0.01 in parentheses 5 squared plus 1.18 times 5 plus 2. The third step is to solve and simplify. Your answer ends up being 7.65 feet. The next part of this problem is, suppose the ball was not blocked but continued on its path. How far down the field would the ball go before it hit the ground? To solve this, you set h to 0 and solve the equation. This is where the ball crosses the x-axis again. The answer is 119.6 feet. You can find this by using your graphing calculator. The last part of this problem is, the linear equation h equals 1.13x plus 2 could model the path of the football shown in the graph. Why is this not a good model? This is not a good model because it does not represent a parabola, so the ball would never come down. A parabola starts down and ends down, but this is a linear model and would only go up.